Switchboard was set up in Boston in 1877. On January 17, 1882, Leroy Furman received the first patent for a telephone switchboard. A Bell telephone, the first Bell Telephone Company started in 1878. This is now known as the American Telephone and Telegraph Company, AT&T, which was incorporated in 1885. Ernest Schneider Hoover began working for Bell Labs in 1945, and in 1971 she patented the first computerized telephone exchange. Exchanges and rotary dialing at the first regular telephone exchange was established in New Haven in 1878. Early telephones were leased in pairs to subscribers. The subscriber was required to put up his own line to connect with another. In 1889, Almond B. Stroger, a Kansas City undertaker, invented a switch that could connect one line to any of 100 lines by using relays and sliders. This switch became known as the Stroger switch and was still in use in some telephone offices well over 100 years later. Almond Stroger was issued a patent on March 11, 1891 for the first automatic telephone exchange. The first exchange using the Stroger switch was opened in La Porte, Indiana in 1892, and initially subscribers had a button on their telephone to produce the required number of pulses by tapping. An associate of Stroger's invented the rotary dial in 1896, which replaced the button. In 1943, Philadelphia was the last major area to give up dual service, rotary and button. Pay phones in 1889. The first coin-operated telephone, or payphone, was patented William Gray by Hartford, Connecticut. Gray's payphone was first installed and used in the Hartford Bank. A touch-tone phones in 1941. The first touch-tone system that used tones in the voice frequency range, rather than pulses generated by rotary dials, was installed in Baltimore, Maryland. A cordless phone. In the 1970s, cordless phones were introduced. In 1986, the Federal Communications Commission, or FCC, granted the frequency range of 47 to 49 MHz for cordless phones. Granting a greater frequency range allowed cordless phones to have less interference and need less power to run. In 1990, the FCC granted the frequency range of 900 MHz for cordless phones. In 1994, digital cordless phones, and in 1995, digital spread spectrum, DSS, were both respectively introduced. Both developments were intended to increase the security of cordless phones and decrease unwanted eavesdropping by enabling the phone conversation to be digitally spread out. Cell phones. In 1947, research into cell phones technology began with an examination of the limited mobile car phones of the times. Scientists realized that by using small cells, range of service area, with frequency reuse, they might be able to increase the traffic capacity of mobile phones substantially. Topic 3. Criteria for selecting a network for information dissemination. Selecting a telecommunication network. The early history of mobile technology. In 1857, Clerk Maxwell derived a theory of electromagnetic radiation, which Guglielmo Marconi used as a basis for the invention of radio transmission in 1901. This was a great achievement. However, it was unable to achieve reasonable data transmission rates for over a half-century. The first precursors to modern mobile telephony were introduced in the late 1940s in the United States and in the 1950s in Europe. These early mobile phones were heavily constrained by limited mobility and poor service. The devices were heavy and also extremely expensive. 1G network. A 1G, first-generation cellular phones. In the 1970s, the first generation, or 1G, mobile networks were introduced. These systems were referred to as cellular, which was later shortened to cell, due to the method by which the signals were handed off between towers. Cell phone signals were based on analog system transmissions, and 1G devices were comparatively less heavy and expensive than prior devices. Some of the most popular standards deployed for 1G systems were Advanced Mobile Phone System, AMPS, Total Access Communication Systems, TACS, and Nordic Mobile Telephone, NMT. The global mobile phone market grew from 30 to 50% annually with the appearance of the 1G network, and the number of subscribers worldwide reached approximately 20 million by 1990. 2G network. A 2G, GSM, and GPRS networks. In the early 1990s, 2G phones deploying GSM technology were introduced. Global System for Mobile Communications, or GSM, uses digital modulation to improve voice quality, but the network offers limited data service. As demand drove uptake of cell phones, 2G carriers continued to improve transmission quality and coverage. The 2G carriers also began to offer additional services, such as paging, faxes, text messages, and voicemail. The limited data services under 2G included WAP, HSCSD, and MLS. 2.5G, an intermediary phase, 2.5G was introduced in the late 1990s. It uses the GPRS standard, which delivers packet-switched data capabilities to existing GSM networks. It allows users to send graphics-rich data as packets. The importance for packet switching increased with the rise of the Internet and the Internet Protocol, or IP. The Edge network is an example of 2.5G mobile technology. 3G, GSM networks, and advanced multimedia streaming via mobile. The 3G revolution allowed mobile telephone customers to use audio, graphics, and video applications. Over 3G, it is possible to watch streaming video and engage in video telephony, although such activities are severely constrained by network bottlenecks and overusage. One of the main objectives behind 3G was to standardize on a single global network protocol instead of the different standards adopted previously in Europe, the US, and other regions. 3G phone speeds deliver up to 2 Mbps, but only under the best conditions and in stationary mode. Moving at a high speed can drop 3G bandwidth to a mere 145 kilobits per second. 3G cellular services, also known as UMTS, sustain higher data rates and open the way to Internet-style applications. 3G technology supports both packet and circuit switch data transmission, and a single set of standards can be used worldwide with compatibility over a variety of mobile devices. UMTS delivers the first possibility of global roaming, with potential access to the Internet from any location. 3.5G, an intermediary phase, 3.5G was introduced in the late 2000s. It integrates WCDM technology on the GSM platform to improve packet switch data, Internet, streaming via the mobile. The WCDMA is known to support data services compared to the GSM technology in terms of speed and streaming quality. It allows users to send graphics-rich data as packets. The importance for packet switching increased with the rise of the Internet and the Internet Protocol, or IP. For 4G, high-speed 4G mobile networks, the current generation of mobile telephony, 4G has been developed with the aim of providing transmission rates up to 20 megabits per second while simultaneously